So just like a regular proof, you draw a line. I'm going to sort of draw my line like this and cheat a little bit. Because I hope you can see that the right-hand side is sine x. There is not much you can do with sine x. It's already sine. And yeah, there's really nothing. It's a single fraction. So that side is going to be really small because there's nothing really I can do. All that we have on this side is sine x. But on the other side, I have sine of pi minus x. And if I think of this as my alpha and this as my beta, I could use my sine alpha minus beta formula. I'll write it out. Sine alpha cos beta minus cos alpha sine beta. And at first it might seem like, why would I want to do that? I'm making it more complicated, okay? But in this situation, if I expand this one, I'm going to get sine pi cos x minus cos pi sine x. And pi is on your pi plate. So when I look at pi, sine is my y coordinate. This is going to be 0. When I look at cos, it's on my pi plane. It's -1. So 0 times cos, that's going to go away. A negative times a negative is going to be positive. I'm done. So we can also get proofs that now include sum and difference identities. And now you have a second method to solve some of the questions that we did on our quiz. So on the quiz that you just got back, question number 10 said one expression equivalent to sine theta minus pi is. You solved that one in chapter 6 with graphs. This would be the sine graph, move pi to the right. But now you could also solve that same question by using an alpha minus beta formula. So we have another way of solving a question we did on the quiz that we had just the other day. That was question number 10. Because if I expanded this with alpha minus beta, I would get sine theta cos pi minus cos theta sine pi. And this is sine theta times -1 minus cos theta times 0. So I find out that it's equal to negative sine theta. And that was one of the options on the multiple choice. But instead, where we were at in chapter 6 is we would have graphed this and said, if I took the sine graph and I moved it pi to the right, it matches up with the negative sine graph. So we're seeing that, and this is the powerful thing that we're moving forward in pre-calculus. A lot of math questions we can understand and solve graphically and algebraically. Sometimes a graphical solution is hard and an algebraic solution is easy. And sometimes an algebraic solution is hard and a graphical solution is easy. So being able to understand both can sometimes lead us to an easier way of solving a problem. So that's why we do a lot of graphing and a lot of algebra in grade 12 pre-calculus. Okay, did I give you questions for this one yet? No. Can do number 9, 10, 11, and 14.